Saturn. A colossal planet, a true giant, most famous for its stunning icy rings. But Saturn is much more than its beautiful accessories. When we gaze at Saturn, we see a pale gold color. This gentle hue comes from the uppermost layers of its clouds. These clouds are made of tiny ammonia crystals. Sunlight scatters off these crystals, painting Saturn with its characteristic golden sheen. The atmosphere is mostly hydrogen, with helium as the next most common ingredient. Saturn isn't massive enough to ignite into a star. It also holds traces of methane, ammonia, and water ice. This atmosphere is not calm or still. It is a place of extreme and rapid winds. Winds that race around the planet at incredible speeds, over 1,000 miles per hour in some places. These powerful jet streams create the banded patterns we observe. Giant storms, some larger than Earth, can also brew. Saturn's visible face is a dynamic, ever-changing canvas, a testament to the energy churning deep within, a cosmic jewel, unlike any other we know. Now let us venture deeper, past the visible clouds. Imagine descending into Saturn's immense atmosphere. Sunlight fades quickly as we go down. The pressure begins to mount intensely, thousands of times greater than on Earth's surface. This incredible pressure changes the very nature of hydrogen. The hydrogen gas gets squeezed, becoming denser. Eventually it transforms into a liquid. This is an ocean of liquid molecular hydrogen, stretching down for tens of thousands of kilometers. A vast global sea hidden beneath the clouds. Deeper still, the conditions become even more extreme. The pressure reaches millions of Earth atmospheres. The temperature soars to thousands of degrees Celsius. Here, hydrogen undergoes another astonishing transformation. The intense pressure breaks apart the hydrogen molecules. It even strips the electrons from the hydrogen atoms. These electrons move freely, making the hydrogen electrically conductive. This exotic state is called metallic hydrogen, a hidden realm of Saturn's mysterious depths. We continue our descent towards Saturn's very center, past the swirling clouds beyond the liquid hydrogen, through the strange ocean of metallic hydrogen. What lies at the very core of this gas giant? We cannot see it directly, of course. The layers above are too thick, too opaque, so scientists rely on models and indirect measurements. One leading theory suggests Saturn has a distinct core, a relatively small but incredibly dense region. This core would be made of heavier materials, things like rock, iron, and nickel perhaps, similar to the materials that make up Earth, but compressed to unimaginable densities. Another possibility is a fuzzy core. Instead of a sharp boundary, it's more like a gradual transition. The heavier elements might be mixed with the metallic hydrogen, forming a dense, soupy mixture at the center. Whatever its exact nature, the core is extreme. Temperatures there could be over 10,000 degrees Celsius. Understanding this core is key to understanding Saturn. The heart of Saturn still holds many tantalizing clues. Section 4. Exotic phenomena within rains of helium and diamonds. Saturn's interior isn't just about layers of hydrogen. It's a dynamic place with some truly bizarre weather. Under the extreme conditions found deep inside Saturn, one such strange occurrence is helium rain. Helium droplets condense out of the mixture like raindrops forming in Earth's atmosphere. These helium droplets slowly sink downwards, percolating through the metallic hydrogen towards the core. And if helium rain isn't strange enough for you, how about the possibility of diamond rain? Deep inside, the intense pressure can break methane molecules apart, releasing carbon atoms. These carbon atoms could be squeezed together, forming diamonds. These exotic rains are not just curiosities, they have real effects on Saturn's structure and energy. Section 5. Saturn's inner warmth, more heat than meets the eye. Saturn radiates significantly more heat into space than it receives from the sun. This means Saturn has an internal heat source. Part of this internal heat is leftover warmth from its formation. This primordial heat gradually leaks out, contributing to the energy it radiates today, but this alone doesn't explain all the extra heat. The helium rain plays a crucial role. As helium droplets condense and fall inward, they release gravitational potential energy. This energy is converted into heat. This process acts as a significant ongoing heat source for Saturn. It drives powerful convection currents within Saturn. Hotter material rises, cooler material sinks. This churning motion helps generate Saturn's magnetic field, a planet that makes its own weather in a way. Section 6. The Explorer's Challenge, probing the unseen interior. Exploring Saturn's interior directly is incredibly challenging. The first major hurdle is the immense pressure. Any probe we send would be crushed long before it reached the metallic hydrogen layer. Then there's the extreme temperature. Even if a probe could withstand the pressure, the rising temperatures would melt or vaporize it. We don't have materials that can survive such conditions. Saturn's atmosphere is thick and opaque. We cannot simply look through it with telescopes, so direct visual observation of deeper layers is impossible. We have to rely on indirect methods, clues gathered from afar or from orbit around Saturn. Scientists use techniques like studying oscillations and waves within the planet. These can be detected by subtle changes in its gravity. These faint signals provide hints about the internal structure. It's a cosmic detective story, piecing together clues. Guided data that scientists will study for decades. Future missions may build upon its findings. The journey of cosmic discovery continues.